Lesson 1.5 is officially solving equations and inequalities by graphing. Now, I'm going to say it's kind of an introduction. Okay, it's not the full-fledged solving by graphing. That we'll get into in 1.6. But this is kind of a mini introduction. Because as you notice, these things we're graphing today, they don't have two variables. They don't have an x and a y. They just have an x. And so that's what's going to make things a little bit different by graphing. Now, if I had to guess, a good portion of you have sat and looked at this problem, already solved in your head, and you already know what the answer is. Okay? And I'm not going to argue that. However, the reason I'm taking it very basic on the first one to introduce you, because then we get to something a little more crazy that isn't as easy to just come up with an answer in your head. I'm not going to say it's not doable, but, not as easy. So, when we go to graph this, keep in mind, when we graph something, we need to think in terms of x and y, correct? And you'll notice as we go through this today, these equations just have x's. So, a method you can use, if you're trying, have a graph option, you're trying to look for an answer, is you can break this into two pieces. So what we're going to do is we're going to break into two pieces. I'm going to look at the left. And so the first equation we're going to look at is we're going to graph y equals negative 3x plus 20. Okay, so we're graphing the left side. And then, after we graph the left side, the other option here is we're going to look at the right, and we're going to graph the right side. And in this case, the right is just 5. So then we'll graph y equals 5. Okay, so I know in this first one we're taking a really simple problem and making it more difficult, but it's a method we can use for more difficult problems as you look. Okay, so, okay guys, we've already talked about it a little bit this year. How do you graph y equals negative 3x plus 20? I reviewed it, we've talked about it. What do you know? What form is this in? Is there a slope-intercept form here? Okay, we are looking at a y equals mx plus b. Okay, so with that in mind, what's my slope and what's my intercept? 3/1. Okay, my slope, or in other words, my m, right, is negative 3 over 1. Okay, because the number negative 3 can be put as a fraction. What is that, 20 then? 20 is y-intercept. Okay, when we graph, remember you start with the y-intercept. What are your thoughts about graphing 20? It's a lot. It's, I agree. Not a fan, but should I just count up here 10 spots off my graph? I'm not going to on this one. I need something more specific, more organized. So what are options to make 20 fit on that graph?
Count by 2.
Count by 2s? Count by somethings, yes? Somethings? Count by something other than 1 would be my guess. Now, 2s make sense, because that puts 20 on the very top line, doesn't it? Here's the deal. Whatever you count by, you need to label your graph. Because without any extra labels on your graph, I'm going to assume you're counting by 1s. So in order to do this, I'm going to count by 2s. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now, if you're saying, whoa, I can't fit all this in there, then another option is, could you count like 4, 8, 12, 16, like count every other line, or label every other line, that is? That would be something too. The idea is I just need to be able to see what you're doing. I don't know if you guys can see my numbers. I made them kind of fine there because I want to be able to make them happen, but okay, so y-intercept of 20 means I'm going to be up here. Put your point on the 20. from there, what's our slope of -3/1 tell us? What's my phrase? Rise over run. So now, before we continue, well, rise over run, we're going to go down 3 and over 1. Now, we need to talk about, though, before we continue, how do we want to label our x-axis? Do you want to count by 2s like you did on the y-axis? Or would you just prefer to stay by 1s? I'm fine with either or, but here's what I'm going to say. You need to label it. Because this one counted by 2s, I don't know what you're doing with the x-axis until you label it. So I'm fine with 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or feel free to label every other number. I'm fine with that as well. But what I will say is put labels so we know what you're doing. Okay, especially if you had to scale one side. Okay, so now from 20, rise -3, which means I'm going to go down 3, which in this case is a box and a half. Run 1. Well, since we're counting by 1s, we go over a full box. So I have my point right there. It's between 16 and 18 on the 1 line. Now, you need to continue. Okay? Today is a good example of why when I go overkill with all my points, it's important. So we're going to keep going. I'm going to go down 3 more. 1, 2, 3, over 1. Now I'm on the 14 line. Down 3, over 1. I'm between 10 and 12. Down 3, over 1. I'm on the 8 line. Down 3, over 1. I'm between 4 and 6. I know where I'm headed with this. Officially, you need to at least go that far. You could stop there if you want. I'm going to go one more just for good measure. That puts me on the 2 line. But you at least need to go to that 1 that's on the 5 line. Okay. I also like to do lots of dots because that is about the only way I have a chance of drawing a straight line on the bin cube. I can't use a ruler, so. One thing I will say is I always keep a little container of rulers up here. So if you are a straight line fanatic and you want to borrow one, you're welcome to grab one. Okay, so get that graphed. Are we good? Okay. What about y equals 5? Because now we've got to graph that one. What's y equal 5 look like? I agree. So this motion. Okay, horizontal line, yes? This is, you can think of it if you want as y equals 0x plus 5, but it's a y-intercept of 5, and it's a horizontal line, a rise of 0. So I'm going to put all my dots going to the right. Something happens there eventually if you're doing this correctly, yes? I'm going to attempt to draw my line. Okay. We have a graph, yes? Thoughts about what my answer is? What's important to notice on this graph here? What are you saying, Jackson?
They cross.
Okay, they cross, yes? Okay, that intersection point is important. What is that intersection point? That is the ordered pair what? 5, 5. Now, lesson 1.6, we'll be looking for that whole answer. That whole thing will be your answer. For today, with what we're doing, we took one equation with one variable and tore it apart, yes? What's the only variable we have here? X. For today's purposes, I'm only asking for x. So what's my solution? X equals 5. Okay, that's for today's purposes. And that's because we're just working with one original equation that we separated into two. So, as you're going through today, you're always going to be looking for the x-coordinate. Okay? Questions on that first one? Okay. Well, I think some of you have moved on without me, which is good. Let's look at the second one. We're going to do the same type thing. I'm going to break it into two parts. My left. Notice what we're graphing here. We're going to graph y equals the absolute value of x minus 4. Okay. I've taught this year. You need to be getting to a point where this was something that was on the quiz technically. What does this graph look like? Absolute value. Absolute value is what shape? V? Absolute value V, yes? Okay. So whenever you see absolute value, your brain needs to be saying, oh yeah, that's going to be a V. What do we know about this V? Okay, as in, which way is it going to move? It's going to move right 4? Yes? Does the green paper help you still? Or the chart's been in your notes a couple of times? Yes. But the minus 4 is in with the x. That's left or right, opposite the sign. And that is a right 4. So those green papers are still helpful. So we're going to take this absolute value v and we're going to move it right 4. Sound familiar? So I'm going to take my v normally starts at 0, 0. We're going to go 4 right. What do each side of my v do? What does each side of my v do? Yeah. And it's just what? 1 and 1, yes? Over 1, up 1, over 1, up 1, over 1, up 1. Now, A, so I can draw straight lines, but B, because I need to find some intersection points, I'm going to make lots of dots. Okay? That V is going to extend. Make as few or as many dots as you want. You'll decide later if you made enough or not. But because there was no number out front of the x, we just went up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Okay. So I'm expecting you know how to graph an absolute value v, right? Now, what about the right half? Now we're going to graph y equals 1/2 x plus 1. What shape is this? Just a line, yes? Typical everyday line, y equals mx plus b. So you're going to have a y-intercept of 1 and a slope of 1/2. Graph your y-intercept of 1. So you're going to go up 1 on the y-axis. And what's our phrase for slope again? Rise over run. So from this point, I'm going to rise 1, run 2. I'm going to keep going. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. If you want, you could reverse it. You could go down 1, left 2. Okay, what are you noticing? What are you noticing here?
Is V twice.
Yeah. Depending on how the line is set up, a V and a line are going to cross twice. Okay? So that means instead of having one answer, we have two answers. Okay? So yes, I need to talk about both. What are these ordered pairs? This ordered pair, this first ordered pair was what? 2, 2. And what's this ordered pair over here?
10, 6.
Okay. What are my answers? 2 and 10. Okay, remember, we just want the X values for what we're doing today. Because what I'm trying to give you is a way, the first one not so much, but the second one, how can we solve this using graphing? That's what I'm trying to give you an option of. Okay, in Savvas, some of your graphs are the multiple choice type, where they're going to show you 4 graphs and say, okay, which one is the appropriate graph to represent the problem? Some of them you're going to be graphing on your own. Okay? Questions here? You can graph 2 lines or a line and a V and figure out where they intersect. Okay. Well, what changes in the bottom section? Mm-hmm. So now we're solving an inequality by graphing. You can probably guess we're going to do a similar process. The difference is at the end, we're going to be looking for, yes, where the graphs intersect, but we're going to be looking for where one graph is less than or greater than the other graph. Okay? Now, x plus 3 is what to 7 minus x? What sign is that? That is our greater than sign. Do we know that? I don't know. I would say we should, but I know some of us struggle with it. So, by all means, write yourself a little cheat sheet if you can't remember which one's which, right? By all means, write it down. Now, similar to last time, I'm going to take the left, and we're going to graph. And we're just going to graph the regular equation. So we're going to graph y equals x plus 3. We'll worry about the less than greater than business at the end. So what do we know about y equals x plus 3? It has a y-intercept of 3 and a slope of the invisible 1, yes? And what is 1 as a fraction? 1 over 1. So, y-intercept of 3 means I'm going to go on the y-axis, always up or down, guys. Up 3. A slope of 1. Rise 1, run 1. I would put in a decent amount of points. Can you always go back and add points though if you don't get enough? Okay. You shouldn't ever be guessing on where the intersection point is today. Okay. If you have to guess where the intersection point is because they didn't match up exactly, then my thought is you probably made a mistake. Okay. No guarantees, but you probably made a mistake because I don't think Savvas is going to, ask you to graph something by hand and then it'd be all crazy. Okay, so I have this line. And have you worked on the other piece? We're going to graph the right. How do you feel about 7 minus 3x? Do you like it or do you prefer it switched? Okay, so if you want to switch it, now I'm going to put the x term first, so it's a negative 3x and a positive 7. Okay, Same questions as earlier. We have a y-intercept of 7 and a slope. What's -3 as a fraction? -3/1. Graph away. Y-intercept of 7. I'm going to go up 7. Slope of -3. I put the negative on the 3, so I'm going to go down 3, right 1. Down 3, right 1. And I'm really just putting in more points. I can see where they're going to cross. I'm really just putting in the points right now to help me get a straight line. Remember, you can also reverse and go up 3/1. What do you notice? Where do these lines end up crossing? At 1, 4. Now, keep in mind, yes, 1 is part of my answer, but my answer is not just x equals 1. What we've got to decide here is my answer x less than 1 or x greater than 1? So you have to look at what our question was. Our question is x plus, where is x plus 3 greater than 7 minus 3x? Now, I'm going to use my color coding. Where is the purple line greater than the green line? And I'm going to write that out, and then we'll examine what I mean by that. So where is my purple line of y equals x plus 3 greater than, and what is it? My green line of y equals 7 minus 3x. Okay, that's the question you're asking yourself. Where is purple greater than green for my screen? So, when we're looking at a graph, where is purple greater than green? That means where is my purple line higher than my green line? So all of it is in relation to that intersection point. Okay? On the left side of 1, so on the left side of my hand, which is higher? In that case, the green line is greater than the purple line. Because on the left, the green line is above the purple line, yes? What happens on the right side of my hand? My purple line is above my green line, yes? Are you with me here? So vertically speaking, where is my purple line greater than my green line? Where is my purple line above my green line? And that's over here. Okay, because purple is higher than green. Now, the question becomes, which side of 1 is that? Is that to the left of 1 and we say less than, or is that to the right of 1 and we say greater than? And that is where?
Right.
To the right of 1. So my official answer is going to be x greater than 1. Have I explained that part somewhat okay? It doesn't seem challenging, but it gets confusing figuring out up and down, left and right, I feel like. Okay. So that 1 is still important. It's still the x value. It's just a matter of figuring out less than or greater than. Ready to try the other one? Okay, same thing we've been doing. Let's break it into pieces. I'm going to start with the left. Oh, do we want to say which sign is that up there? Well, if the other one was greater than, that means this one is the less than sign. And again, Label them if that's going to keep you organized later. So we're going to graph y equals negative x plus 5. What do we know? Negative x plus 5. 5 is my y-intercept. And my slope is what? The invisible negative 1, which as a fraction is negative 1 over 1, or if you prefer, 1 over negative 1. So y-intercept of 5 is 5. Slope of negative 1, I'm going to go down 1. That's my negative. Right 1 is positive. Down 1, right 1. Down 1, right 1. I'm going to go down 1, right 1 a bunch. I also can reverse and go up positive 1, left negative 1. Up 1, left 1. Let me remember where I need to make sure we hit. Okay, we've hit the important point. That's what matters. Okay. As I said, to me it's important you put a bunch of dots because I don't want to have to guess what my answer is. There shouldn't be any guessing today. Okay, other piece. Have you started graphing it? Graph y equals 1/2 x minus 1. Y-intercept of negative 1 and a slope of 1/2. Y-intercept of negative 1. On the y-axis, I'm going to go to negative 1, which is down 1. Slope of 1/2 tells me to rise 1, run 2. Rise 1, run 2. Rise 1, run 2. I got what I need, yes? Reverse it if you feel the need. This is why I have points, because I think my green line, I'm not sure, really went through any of my points. But that's why I have points, because that's what matters. What point is important here? Looks like they are meeting at 4, 1. So my answer is either going to be what? X is less than or greater than what number? 4? Okay. Now, think carefully. This time we're asking ourselves, where is, for me it's my purple line, so y equals negative x plus 5. And where is that less than the green line, which is y equals 1/2 x minus 1. Okay. Where is my purple line less than my green line? So where is my purple line below my green line? And it's all going to be in relation to 4. Is my purple line less than my green line over here? Or is my purple line less than my green line over here? What are we thinking? Do I want to say x less than 4 or greater than 4? You have an answer in your head at least? Because what I see is, where's my purple line less than my green line? Here's where my purple line is below my green line, yes? Which side of 4 is that on? The right side of 4, so my answer is x is greater than 4. Okay? I had a lot of people saying less than this morning. And let me point out, just because this is less than, does my answer have to be less than? It does not. Okay, so that to me is probably the hardest part of the lesson, figuring out less than, greater than on that one.
So if the purple line was on the left side, would it be less than?
Like if it was over here where the purple line was below green,
Yeah.
then yes. Yeah. If you're to the left of the x value, it's less than. If you're to the right of the x value, it's greater than. Okay, questions there? Okay, we've done the hardest part of the lesson, in my opinion. Ready? Okay. The back page says, use what? Graphing technology to approximate the solutions to the nearest 10. In Savas, it will either use the phrase to use a graphing utility or graphing technology. I think those are the two phrases they use. What do you guys know how to use? What have we used already this year? Desmos. This piece of the lesson is all about Desmos, folks. Grab your iPads out. Okay? Now, hopefully as you look at it, are you saying, oh, I'm glad I don't have to graph these by hand? To be honest, you don't know how to graph those parabolas by hand yet, unless you remember your Algebra 1 parabolas graphing, which I know you know. So, we're going to do this exactly like we already did this, though. We're going to take the left, and we're going to make it one equation. So we're going to graph y equals negative x squared plus 8x minus 13. And then we're going to take the right, and we're going to graph y equals absolute value of x minus 4. Okay? And it's all about using Desmos, just like it was earlier. So I'm going to attempt to hop over to Desmos. I think I'm a little more prepared this period. And I'm going to do just that. So y equals, they want negative x squared, which negative in this case you just get to use a minus. X squared is from the a, plus 8x minus 13. Should have an upside down parabola on the first one, yes? And then you can hit enter and go down to the next line or open a new line. Let's see, where's absolute value? Well, okay. Y equals, absolute value is right here, yes? And then it's x minus 4. And then you can tap outside of it or arrow outside of it. And there you go. Does your graph look similar to my graph? It should, right? Okay. This isn't anything new. We've graphed using Desmos this year already. Now, what do we need to know here? Where they intersect again. Now, can you already see what's going on here where you intersect? Is it at a nice, neat intersection point? No, but does that matter? No, because you're using Desmos. This is the one time today in this lesson where if you get ugly decimals, that's okay because Desmos is telling me the answer. Okay? So remember, you can touch the intersection points to find what they are. Looks like they should be those right there, if I've done everything right. And what do we only need here? We only need the x values, yes? Okay, you only need the x values. And my answer key, I have them to the nearest tenth. That's what the directions say there. Savas might be something similar. Now, do remember you can pinch and zoom on the graph, right? I know first hour someone had theirs going crazy. I think there's a way somewhere here where you can, like, I don't know. I thought there was some place where you can, like, reset so it just goes back to a normal grid, but I don't remember what that is, so. Okay. Can I go back to my other screen? Are we okay? I didn't get all the way around the room, but. So, I'm going to put a basic graph. That absolute value V was moved over 4. So the absolute value V looked like this. Okay. The upside down parabola looks like, was it vertex at 4, 3 maybe? Is that what I'm seeing?
Yes.
Okay. And then the first set of points go over 1, down 1. The next set of points would go over 2, down 4. I'm not even sure if it says use graphing technology. I don't know if you have to graph them in Savas or not. I don't remember. But if you want a visual, this is what your graph would look like. All I need are those 2 points right there, which I have written in my notes as approximately. It's definitely not precise. 2 point something and 5 point something. Approximately 2.7 and 5.3. Okay? Did we all eventually get Desmos cooperating? That is, if we have a working iPad. Did you eventually find the internet? No, we have not. Still. Okay. And that's still be difficulty with that. Okay. The other example is similar, yes? Okay. The other example would be doing the same thing, where you would be graphing the left, y equals x squared plus 2x minus 1, and you would be graphing the right, which is y equals absolute value of x plus 2 plus 2. Realizing that's not x plus 4, is it? You can't add across the absolute value pieces there. And it'd be the same thing, looking for those intersection points. I don't know if I really need to graph these for you or not, but have you guys found answers? Or have you done this one yet? I know, but I still have to teach again. So I could also save them for my next period when I have to teach it again, which is honestly what I was doing. So yeah, if you guys are realizing, I just turned those graphs off by clicking the circles here, and that way my equation is still there, but then it's just not showing, it's out of my way. What is it, x plus 2 plus 2? Yeah. Make sure when you're typing the x plus 2 that you move outside for the second plus 2, because that's going to move that v. Okay. And if I've done mine correctly, you should have a graph that looks like that. What are these points? Have you gotten them? That agrees with my answer key. I have a negative 3.3 and a 1.8, because again, we only want the x values, right? Okay, so I have the parabola that is moved 2 left and 2 up. And then I have, excuse me, that's the absolute value v. And then I have the parabola that is moved, is it 1 left and 2 down, it looks like? Okay. So those are your 2 pieces if you want to graph them on your other page. So I'm going to do my v first. It was left 2, up 2. So there's my vertex, left 2, up 2. And again, just your basics here. And then my parabola, the vertex was, what did I say, left 1, down 2? And it is just a 1x squared parabola. We'll talk more about that later, but because it's just 1x squared, it is over 1, up 1 for your first set, back to vertex, over 2, up 4 for the next set. Okay. Negative 3.3 and 1.8 is what I have. Okay. Because I had to round, I did use the approximate equal sign, which is the squiggly equal sign. That's just saying x is approximately those values. Okay. So finish up what you need there. When are you to use Desmos in homework tonight? When it says graphing utility, graphing technology. Otherwise, should you use Desmos on everything? You're not going to get the good practice, okay? Because I need you practicing how to graph some of these things. Okay, so graphing technology, yes, this is your graphing technology. If it just tells you to solve the problem, then stay away from Desmos. Okay? So you have about 10 minutes. You can get a little bit of work done in Savas. As I said, I know some of them are multiple choice. So you actually have to graph by hand, though. And I'll leave this up here.